Hi students, so myself Vikas Agrawal, Master Teacher for Physics. So today I am here to discuss few problems of IE and PHO level. In fact, these problems are from previous year IE and PHO papers only. So we'll discuss those questions and I'll just give you the flow of the session quickly. So what I'm going to do, I'm going to show you the questions that we are going to discuss in this session first, because I'm pretty sure that many of you would want to have a look at the question and try it out themselves before looking at the solution that I'm going to present. So first of all, I'll be showing you the questions that we'll be discussing in this session. There will be two questions that we will be discussing, and I will be giving you one question as a teaser question as homework. Okay, so I'll show you the questions, then I'll show you the answers also. Then we'll discuss the solution of the question. I'll present the solution of the question, and finally I will give you the teaser question. So this is going to be the flow of the session. Okay, so this is the first question that I'll be discussing in this session. So I'll get off from the front of the screen. You can have a look at the question. At this point, if you want to attempt the question, you can pause the video here and you can attempt the question, and when you come back, the next slide will show you the another question, and then you will see the answers of these questions. So if you want to attempt this question on your own, you should pause the video right now. This is the second question that we are going to discuss. This is not the complete question. The question was a long one, so it took 2 slides for me to put the question here. So this is one part of the question. Again, you can pause the video here and you can have a look at the question, and this is the remainder of the question. So again, you can pause the video here and you can now attempt the question. Right, so I'm assuming that many of you would have paused the video and you have attempted the question, and now you want to have a look at the solution. Maybe not the solution, you want to have a look at the answer. So guys, answer to the first question is this: 1.386. This is 2 times of log 2, log to the natural base. Okay, so 2 ln 2, that's the answer for the first question, and these are the answers for the second question. The second question had multiple parts in it, so these are the answers. I'll again get out of the frame so you can have a look at the answer. You can pause the video, you can compare your answers. Now, assuming that you have tried the question, assuming that probably you have got the answers, maybe you could not get answers to some of the parts, or maybe you could not get answer to any of the part, I'll help you to solve these questions now. So this is the first question that we are going to have a look. So let's say what this question says. This question says that there are several men who are standing on a railroad cart, on a stationary railroad cart, and because of a bomb scare, the men starts jumping off the cart. So because of their jump, the cart will receive an impulse, and because of that, the cart will start moving. So we have to estimate the velocity that the cart will acquire once all the men would have jumped one by one, and we have to compare it with the case when all the men would have jumped together. So we have to find out 2 kinds of velocity. The first one, when men jump one by one. The second one, when all the men jump together, and we have to take the ratio of these 2 velocities. So this is what we have to do. So guys, the trick here, which was given in the question, the trick here is that the number of men who are standing on the railroad cart, we have to consider that number to be very large. Now let's understand what this would mean. Okay, let's understand the meaning of this. So if I draw a railroad cart here, just a representation, okay, and if I assume that several men are standing here, okay, the number is not given, we have to assume it to be large. Let's say the mass of this railroad cart is capital M, okay, and the mass of one man is small m, okay, and the total number of men is n. So n persons are standing. The question says that n is large. The question also says that the total sum of the men, the total sum of masses of the men is same as the mass of the cart. So this would mean that m into n should be equal to capital M. Okay, and given that n is large, so that would mean that the mass of one man is very small as compared to the mass of the cart. So basically we can consider this mass to be small. Okay, and the people are jumping one by one, and because of that, the cart is acquiring some kind of velocity. Okay, now this question is an easy one if you recognize that whatever is happening in this question is something which happens in rocket also. In rocket also similar situation is there. There is a total mass, mass of the rocket body plus mass of the fuel. Then the fuel keeps on ejecting with some velocity relative to the rocket, and because of that the rocket body accelerates, it acquires some velocity. Okay, so this question can be addressed once you realize the similarity between the given situation and the rocket equation. Now the rocket equation says that the thrust experienced by a rocket will be given by R into V. What is R here? R is the rate at which the fuel burns, or the rate at which the mass decreases, mass of the rocket decreases, and V is the speed with which the gases are leaving the rocket relative to the rocket, which we also call as the exhaust velocity. Okay, so this equation, solving this equation, when we solve this equation, we get that the difference in the velocity that is created in a rocket is given by the exhaust velocity into ln of initial mass of the rocket divided by final mass of the rocket. So this equation is what we call as popularly called as rocket equation. So once you realize that this situation is similar to what we observe in rocket, you can simply use this equation and that will do the job for you. In the present scenario, what is happening, let's assume that the men are jumping off the cart with some particular velocity v, okay, and the initial mass would be the mass of cart plus the sum of masses of men, and the final mass would be the mass of cart itself. What's interesting here is to note that this value is independent of R. This equation is independent of R. So irrespective of whether the mass flow rate, the rate at which the mass was burnt is less or more, for a given amount of mass which is lost with a relative velocity or exhaust velocity V, the delta V that will be produced will be given by this expression. So using this expression, we can then directly say that the velocity that rocket will acquire, or sorry, the cart will acquire after all the men have jumped off would be given by V ln. The initial mass is the mass of cart plus the mass of all men divided by mass of cart only. According to the given situation, the mass of cart and the total sum of masses of men is equals to twice the mass of cart, because these two are equal. So this simply becomes V ln 2. Okay, so this is the speed that the cart would acquire if the men jump one by one. Okay, now we have to compare this speed with another speed, the speed that the cart will acquire if all the men jump together. Now this situation is comparable to the recoiling of a gun. Okay, I'm pretty sure, I'm assuming here, actually I'm not pretty sure, but I'm assuming here that you have heard this concept or you have learned this concept of the velocity of recoil of a gun. So if there is a gun of a mass m and in it there is a bullet of mass small m, okay, and if we fire the gun, okay, if we fire the gun, the bullet leaves the gun with some velocity, the gun recoils with some velocity, let's call it as VR. In these situations, we are given the muzzle velocity of the bullet. The muzzle velocity, let's say it is given to be V. Okay, then we write the recoil speed of the gun as mass of bullet into the muzzle velocity divided by the total mass before the firing. That is the mass of bullet plus the mass of gun. Now here, again, I'm assuming that you have heard about this. Okay, if not, then try learning about this theory and then the situation will become very obvious to you. So presently similar thing is happening. So we can compare the cart with a gun. We can compare the total mass of all the men as the mass of the bullet. Okay, so when these men jump with a relative velocity u with respect to cart, and when they jump together, the cart would acquire a velocity in the backward direction, which can be written by this expression. So here m represents the mass of the bullet, so that will become the total mass of all men. So that will become n into m, then v will be here, and then here n m plus capital M, which becomes v by 2, because this value is same as m. So m upon 2m, so v by 2. So the two velocities we have got. This is the speed of the cart if the men jump one by one. This is the speed of the cart if all the men jump together. And we were supposed to find out the ratio of these two velocities. We were supposed to find out v1 by v2. So that comes out to be 2 ln 2. So this would be the answer to the first question. Okay, simple question. But the concept that we have used in this question is something that is very popular among the INPHO people. I think several years papers when I check, I found that this particular concept of variable mass or the rocket equation has been used at multiple places. So I thought that maybe I should cover this topic. So here I am, and so this is the first question that we saw. I guess this was a good question to begin with, a simple yet an interesting question. So now, without wasting any time, what we'll do, we'll move to the next question, which is a lot more complicated than the first one. I'm pretty sure that those of you who tried that question on their own must have realized that. So let's try that question. This is the derivation of the rocket equation, and this is what we get as the final answer. Okay, now we have come to this question. Okay, so this was the second question that I displayed, and here we are discussing the performance of a two-stage rocket. Now, what is a two-stage rocket? Okay, so the language describes the two-stage rocket. What has been given here, I'll tell you. So this part of the rocket has mass m as depicted in the figure. Okay, then this is called the first stage of the rocket. So basically this is you can say the solid part or the container. Okay, and here fuel is present. Okay, here fuel is present. Okay, so mass of fuel plus mass of the first stage, the body part. Okay, that here similarly here is the body part, and within this body part there is some fuel present, and this is the payload. This is that thing that we want to send in space. Okay, so we have been told some information about the masses here. The information that has been given to us is, now listen to this very, very carefully, because this question you have to be very careful with the understanding of the language given also. Only then you will be able to address this question properly. So Nm stands for the overall mass. Okay, I think I've clicked somewhere wrong. So Nm stands for the overall mass. Okay, overall mass means first stage body part plus fuel plus second stage body part plus fuel plus payload. So we can say that the rocket can be divided into 5 parts, the masses of which are non-zero. The first stage body part, the fuel that will be utilized in first stage, then second stage body part, then the fuel that will be utilized in the second stage, and the payload. So there are 5 components that possess mass, and the mass of payload is given to be small m. The overall mass is given to be n times of small m. Okay, so that information is given to us, and then the mass of second stage body part plus fuel plus payload is small n into m. So let's try to understand the information shared with us about the masses. If I write m1c as the mass of first stage container plus m1f, this is the mass of first stage fuel. So mass of first stage container plus mass of first stage fuel, this would be the total mass minus small nm. Understand this, small nm is the mass of second stage everything, container plus fuel plus payload. Okay, so mass of first stage container plus first stage fuel is this. Similarly, mass of second stage container plus mass of second stage fuel would be, I'm pretty sure that you can guess it now, it would be small n into m minus m. So whatever language is given to us in the question, first you have to carefully figure out the information related to the masses. Okay, so these two we have figured out. Now there is an additional information given in the question. That information says that for any stage, the ratio of mass of container divided by the mass of container plus fuel is R. Okay, something related to that is written here. I can show it. It says the mass of second. It says in each stage the ratio of container mass to the initial mass. Initial mass is container plus fuel is R. So this is something important. So what it means, this is the mass of container plus fuel. Okay. So if I write mass of container divided by mass of container plus fuel for any stage. Okay. Therefore I have not used any subscripts, like I did not use a 1 or 2 because this is true for both the stages. So this ratio is given to be R. Okay. Mass of container divided by mass of container plus fuel is R. What it means is that if I write mass of first stage container divided by mass of first stage container plus mass of first stage fuel, so that this ratio is R, and we know this sum is Nm minus small nm. So it basically means that mass of first stage container would be R times of capital N minus small n into m. Carefully notice this. In fact, if you're solving this question on your own, this is something that you should take note of and keep it separately, because during the entire question you will be needing these masses. We figured out that there are 5 components in this rocket or in this entire body. So you will be needing the mass of these 5 components separately at different stages of the question. So better note them down separately so that whenever you need any of the mass you can use them. Okay, so M1C we have figured out. Now correspondingly, observe that if I want to write mass of first stage fuel, I simply have to replace this R by 1 minus R. 1 minus R into N minus N. Why? Because the sum of these two should be equal to this value. So just have a look. So when you are writing mass of container, R times the total mass. When you are writing mass of fuel, it would be 1 minus R times the total mass. Total mass means mass of that particular stage body plus that particular stage fuel. Okay, so why I am emphasizing on this part, because this is the segment, you can say, or this is the thought where most of the students have committed the error. If you figure this part carefully and correctly, then the question is an easy one. Then the question is mechanical. When I say mechanical, what do I mean? That then everything that you need to do is something that would be known to you. That part won't be easy. That part won't be difficult. This was the difficult part. So the difficulty in this particular question lies not in the physics. The physics is the usual one. It lies in understanding of the information given to us. Alright, so similarly you can work with the second stage also. Alright, so second stage container mass, how much will that be? That would be R times of this value. And similarly the mass of second stage fuel would be 1 minus R times this value. Okay, so these 4 things if you have written down, the fifth mass is already known to us, it's small m. So once all this is done, then you are ready to do the question, and you will notice this, that if you have figured out these 4 masses carefully and correctly, then you will not face any problem in the remainder of the question. Let's see how. Okay, so the first question says, the A part of the question says that obtain the velocity of the rocket gained from the first stage burn in terms of these parameters. Okay, now there was an important statement in the question that I did not emphasize till now. The question said that after a particular stage fuel is burnt, okay, the container body of that particular stage detaches without affecting the speed of the rocket. So this means that once the first stage fuel gets burned, okay, whatever is the speed acquired by the rocket, that speed will remain as it is until that first stage body detaches itself. The detachment will not affect the speed of rocket. So why is this part important? Why am I emphasizing here? Because see, to use the rocket equation, we need 2 information. We need the initial mass of the rocket, which is very simple, and we need the final mass. Now, what should I consider the final mass here? Should I consider the mass that is left after burning of the fuel, or should I consider the final mass as the mass which is left after burning of the fuel plus detachment of the container body? Here you can pause the video and you can give it a thought. You can tell me your own opinion what it is, and then you can resume the video. You'll know the answer. So the answer would be as the final mass, we should use the mass only after the burning of the fuel, because by that time the container body was also part of the rocket, and by that time whatever velocity the rocket has acquired, that velocity will remain as it is. The detachment will not lead to any change in the speed of the rocket. So pay attention. So therefore this line was important. Now I think if you have written the masses yourself, then this thing is easy for you. It says velocity v of the rocket gained from the first stage. Now guys, since there are two v's involved in this question, one is a small v, the other one is the capital V, and when a person writes, specifically if I talk about myself, when I write with my hand, it becomes difficult to distinguish between a small v and a capital V. So what I will do, I will use v1 for this. So velocity acquired by the rocket after the first stage burn. Okay, it's difficult to distinguish between my small v, my capital V, and my u. Okay, so I will try to use different symbols there. So V1 will be given by the speed with which the gases come out of the rocket, the exhaust speed, into ln into ln of initial mass upon final mass. Okay, now let's try to understand here. The initial mass would be the overall mass, which was capital N times of small m. I hope you all agree with me here. And then what would be the final mass here? Well, the final mass should be the total mass minus the mass of first stage fuel. What do you think, guys? Do you agree with me on this? The total mass minus the first stage fuel. Okay, mass of first stage fuel. So V ln and then capital N small m and then nm. Now what was the mass of first stage fuel? I remember I had to use 1 minus r as the ratio. This multiplied with the total mass of first stage. Total mass of first stage was nm minus small nm. Guys, I'm doing this by my memory. There are good chances that I may commit an error here because I'm writing things, thinking from the start. So keep on noting, alright? I mean, keep paying attention. If I'm wrong, at least you should not commit the same error. So 1 minus m, I think I have not committed any error till now. So this will become, m gets cancelled from numerator and denominator. So n divided by n minus, and here we will be left with 1 minus r into capital N minus small n. Of course, we can now simplify. We have to now expand this. So v ln n upon n, and let's keep the minus here. So this will become n, then minus n minus rn and plus rn. Okay, and finally it becomes v ln n upon n minus n. So n plus n plus r capital N. ठीक है, आई थिंक थोड़ी सी गड़बड़ हो गई है, इसको ठीक कर लेते हैं. ये हो जाएगा n माइनस कैपिटल N प्लस n प्लस r कैपिटल N, right, and minus r small n. Okay, so this becomes v ln, this gets cancelled, n upon n 1 minus r plus n r capital N. So this becomes V1. So this becomes your first answer, right? So guys, देखो, as I said that once you have written the masses carefully, then the question is very easy. If you notice carefully, we have just substituted the masses. We have not done anything else, right? So after substituting of the masses, after knowing the masses, the question becomes easy. So this is the first part. Okay, now this is the answer to the first part. Now we'll try the second part. It says obtain a corresponding expression for the additional velocity gained from the. So we have to find out the additional velocity, right? So this much velocity the rocket has already gained. Now the additional velocity we have to find out. So again, for additional velocity, which I'll prefer denoting with V2, okay, we will use the same formula, V ln initial mass. Now what is the mass of the rocket at the beginning of stage 2 burn. Okay, that would be the total mass. The mass was given as small n into m. Small n into m. So this was the mass of three things: the payload, the second stage body, and the second stage fuel. So initial mass will be this divided by the final mass. Now final mass would be Nm minus mass of second stage fuel. So once you have written this, there is nothing else to be done. Just substitute the value of mass of fuel. That's it. That will do the job. So it will become V ln Nm upon Nm minus mass of second stage fuel. So that would be 1 minus R. Since we are writing the mass of fuel, 1 minus R is the fraction that I will use, and then I have to multiply it with Nm minus m. Right? Again, we wrote this thing initially. So that's it. That's it. A little bit of simplification you can do. So if I do that simplification, what we get V ln, and then mass will get cancelled, so I will just leave n in the numerator, and in the denominator we are getting n, then minus, I'll multiply these two. So small n, okay, small n minus 1, and then minus r small n, and then plus r. Okay, remember masses got cancelled. Okay, so let me just check it out once again. So it is n minus 1 minus Rn plus R. So it looks good to me, and then it becomes V ln small n divided by the n gets cancelled, 1 plus Rn minus R is what we get as the value of U. So you can take note of it, you can notice and I'll just check whether I got the correct value or not. Otherwise all the subsequent calculation will be wrong. So let me be sure. Okay, so we got V ln n 1 plus Rn minus R. Yeah, all good. Right, so now once you have done this, next part says you have to add these two. So we'll add these two, then you'll have the payload velocity W in terms of the parameters, that's fine. Then we have to take capital N and R as constants, and we have to find the value of small n for which W is maximum. Okay, so let's do that. So I guess you can figure out what is to be done next. We have to obtain W by adding U plus V. Once we do that, we will have an expression involving capital N, involving small n, involving R. Out of these three parameters, we have to treat capital N and R as constant, and we have to optimize the expression. So we'll differentiate W with respect to small n, and we'll equate the derivative to 0. We'll try to figure out for what value of small n does that derivative becomes 0. That is the value of small n that we are looking for. So this is mathematics, like what I'll be doing will be mathematics, and it is generally difficult to understand the math done by others. Alright, a better way to understand is to try it out yourself, and if you get stuck, most probably you will not get stuck because the math is very simple here, but in case if you get stuck, then what you can do, you can then come and see what I'm doing here, compare what you have done with what I'm doing, and try to find out any mistake that you may have committed. Alright, so let's do that guys. So for doing that, I'll be needing the expression for W. Since it was a long expression, it was difficult to memorize it, so I have written it down on a piece of page. I'll begin from there. So we have obtained the value of U and V, and I denoted it by V1 and V2. So when we add them, the expression that we get is V ln, and then we get n small n divided by, we get n into 1 minus R square, and then plus n square and 1 minus R into small r, okay, plus R into capital N into 1 minus R, okay, plus R square into capital N into small n. So this is what we get. Quite a long expression, difficult to remember, and hence I wrote it down on a piece of paper and I've copied it from here. Now I will do the calculation. Now, of course, the expression looks intimidating. The moment you see this expression, you may feel that it's too difficult to differentiate. Let's observe it carefully. First of all, let's try to understand that we have to differentiate with respect to small n only, and we have to treat capital N and R as constant. With that thought, let's have a look here. Let's have a look here. It's V ln, okay, then n, that is fine, okay. Now what I'll do, I'll look for n square and I'll try to figure out the coefficient of n square. Okay, so I'll write the coefficient of n square here. This term does not involve any n square. I could see n square here, so that is 1 minus r into r. Okay, 1 minus r into r. I am not able to find n square elsewhere. Okay, so this, I'll just close the bracket. Then I'll look for the coefficient of n. Okay, so I can see n here. Okay, in fact, since we have already used this, let me just circle it so that I do not check the used term again and again. That will save my time. Also, my attention will be focused on the terms which are yet to be used. So 1 minus r square. Since I have made use of this term, let me encircle it. Do I see n anywhere else? Here I see it. So plus r square n. Now I close the bracket. Okay. What remains does not contain small n. So for our purpose of differentiation, we can treat this part as constant. So I'll write it here as r n 1 minus r. Alright, so this makes the expression. Now what I'm going to do, I'm going, see, in fact, why have I written like this? Now you can clearly observe that we have n divided by a quadratic expression in small n. So I write it as n square into alpha. Now what is alpha? This entire thing I'm representing as alpha. Why have I done that? For the sake of visibility, for the sake of my own understanding, and to ensure that I'm not writing long terms again and again. Alright, I'll simply represent all of this by alpha. Similarly, I'll simply represent all of this, let's say, by beta. So it's n into beta, and all of this by c. Alright, now guys, the problem is that once I switch the slide, all of this would be gone. Alright, and again, these alpha, beta, c, they are quite long to remember with full confidence. So I've noted down the value of alpha, beta and c, and I recommend that you also note it down on a piece of paper. If you're solving it with me, note down the value of alpha, beta and c on a piece of paper, and then we'll start differentiating this expression. Alright, so for the purpose of differentiation, let's do one thing. I'm erasing it. I'm pretty sure that if you want to have a look on what is written here, then you can go back a few seconds on the video and you can check. So now we have to differentiate this. So this is basically w. So we have to do dw by dn. So first we'll do this and then we'll equate this to 0. So we'll have v and then ln of this. So I'm pretty sure you're comfortable with differentiation. So n square alpha plus n beta plus c divided by n. Okay, then we have to now differentiate this entire expression. So I'll write the denominator first. Okay, and differentiation of numerator will give me a capital N. Okay, then I will write numerator, and differentiation of denominator will give me 2n alpha. Let me write n, that looks like n, plus beta. Alright, and this entire thing divided by n square alpha plus n beta plus c square of this. So guys, this is what we get after we differentiate. Again guys, this part of video you can skip, you can move forward in the video to see the final expression that I've obtained, because I'm expecting that you guys would be differentiating everything yourself and then you'll be having a look at the final expression. If you are not able to get the final expression, then you should come here and check what I have done. Now this gets cancelled, and though all this is not necessary for me, because ultimately we have to equate this with 0. So when we do this, it clearly tells us that this entire thing should be equal to this entire thing. So it would be better if I simply start solving from here only. Alright, again I'm erasing this because if you want to have a look at this part, you can just roll back the video by a few seconds. So let me put an equality here. N gets cancelled and we are now left with what? We are now left with n square alpha plus n beta, okay, plus c, that is equals to 2n square alpha plus n beta. N beta gets cancelled, so c is equals to 2n square alpha. So the value of n is root of c by, sorry, this 2 will also get converted to 1, so it's c by alpha. So this is the answer that we were looking for. Now what was the value of c? Well, I don't remember it. I partially remember it, but I'm not too confident, so I'll have a look at the value of c. C was r into n, then 1 minus r. This was c. So c by alpha. Now what was alpha? Alpha was n square, sorry, alpha was 1 minus r. Alpha was 1 minus r into r. That was alpha, yeah. So r gets cancelled, 1 minus r gets cancelled, root n is what we are left with. So this is the answer to the question that was asked, that what is the value of small n if we want to maximize w. The answer is root of n. Alright, I hope that many of you have obtained this answer on your own. Alright, so let's move to the next part then. So D part now says find an expression for the payload velocity Ws of a single stage rocket with the same values. Now let's try to understand what does a single stage rocket would look like. So when we are talking this part relates to the interpretation. What do we consider as a single stage rocket in the given scenario now? So we were given this information that this mass was m, alright, and the total mass was nm. Okay, now if we were also told that for any stage, mass of container divided by mass of container plus fuel is r. So what would it mean for a single stage rocket? This is the payload, and now this is a single stage. Now this is a single stage, so I will say that mass of container of this single stage is r times of what? It is nm minus m, and mass of fuel for this single stage rocket is 1 minus r into n minus 1 into m. This is same as this. Alright, so with this we can now talk about the velocity acquired due to a single stage rocket. So we are writing it as ws. Okay, so ws would be v ln initial mass divided by initial mass minus the mass of fuel. So that's 1 minus r into n minus 1 into m. Okay, what you can do, you can finish this calculation by yourself. It's pretty simple, I guess. Alright, so that will give you the value of omega. That is what we are looking for. Now E part says that it is desired to obtain a payload velocity of 10 km per second using rockets for which v is equals to 2.5, r is equals to 0.1. Using the maximum condition for part C, obtain the value of. So guys, D part is done. So this would be the answer for part D. You can simplify a little bit here, alright, and then whatever you get is the answer. And for part E, what we have to do, we have to obtain the value of V1 and V2 by substituting small n as root of capital N. Okay, listen to what I'm saying carefully. So we obtained an expression for V1. I'm hoping that you have noted it down in your copy. If not, go back in the video, check the value, note it down. Similarly, we figured out the value of V2. If you have noted it down, well and good. If not, go back in the video, copy it down. Then in those expressions, replace small n by root of capital N. Once you have done that, you will obtain the value of V1 and V2 in terms of capital N and R only. Once you have done that, then substitute the value of R as 0.1, substitute the value of final velocity, that is W, as 10 km per second, substitute the value of capital V as 2.5 km per second, and obtain the value of capital N. So that's purely mathematics. Substitution in mathematics is what you have to do. Alright. Once you do that, you will get the answer somewhere around 649, somewhere close to 650. And that would be the answer to this question. This part of the calculation, since it involves simple substitution and some basic math, so I'm not doing it here. I'll just show you what I have done. Alright. So basically, whatever solution I have just now given you, that solution is present here in a better font. My handwriting wasn't that legible, so everything is present here. I'll just move through the slides one by one, so that if you want a proper detailed solution, you can have a look at these solutions. So this is part B of the question. Okay, all the calculation that I have done is printed, isn't printed. And guys, keep in mind, while typing, there may be a few typing errors. I've tried my best to eliminate all those errors. Whatever errors I could find, I eliminated them. There is a good chance that no further error is there, but still, if you find something odd or something not matching, then carefully pay attention and figure out whether that was a typing mistake. Okay, it shouldn't be there. Alright, but I'm just giving you a warning. Alright, so we found U as root of C by alpha. We did that. After doing the calculation, we obtained this. Now, when we substitute this value in the expression for V1, that is U, alright, we get this. Similarly, when we substitute the value of small n in the expression for V, we get this. Alright, and these two happen to be same, which means this ratio will become 1. Alright, great. Then omega S, WS, alright, this is the expression. We have got rid of small n. We have substituted small n as capital N, root of capital N. And now these are the values. So we are just substituting the values. So this is the final expression in terms of capital N R. So we are now putting the value of the final speed as 10 km per second. The value of V as 2.5 km per second. The value of N is to be obtained. The value of R is 0.1. So 1 minus 0.1 will become 0.9. And here root of N into 0.1. So this becomes 5, this is 10. So 10 divided by 5 will become 2. Alright, so the next step, you can see 2 is equals to ln of this. Next, we can get rid of the log by using E square is equals to this ratio. So then this denominator is taken to this side. So E square is 7.39 multiplied by 0.9 plus this entire denominator is written here. Alright, now we expand this. These two multiply gives us 6.65. Then the product of these two is 0.739 root of n is equals to root n. Everything else follows simply. So the value of n that we got is this. Right. I hope you enjoyed this question, and I hope you can appreciate that primarily the interpretation of masses in this question was the most important aspect of this question, apart from the usual physics of rocket equation. Like if you know the rocket equation and if you have interpreted the masses correctly, there are good chances that you will solve this question on your own. Alright, so these are the summary of all the answers that we have obtained. Okay, one point that I would like to emphasize here is that the question was intended to highlight how a multi-stage rocket is better than a single stage rocket. But I think that part is yet to be understood. Like we have solved the question, but how is that helping us to figure out that two-stage rocket is better than a single stage rocket? Let's try to investigate that. Let's try to investigate the purpose of the question. So we have been given some value of R. It was given to be 0.1. We were given some value of capital V, that was 2.5 km per second. Okay. Let's try to achieve the speed of 10 km per second using a single stage rocket, and let's see what happens. Let's see what happens. We are doing this to do justice with the intention of this question. So if I try to obtain the same with a single stage rocket, what happens? I put a 10 here, I put a 2.5 here, then I put the numbers, I try to find out the value of n. Once you do all this math, you will realize that the value of n turns out to be negative. what does that mean? Like n cannot be negative, right? So if we are trying to use the given information to obtain a velocity of 10 km per second, I'm getting a negative number, something odd. I don't think there is any mathematical mistake here. Let's further investigate what is happening. Let's further investigate. So for investigation purpose, I've written WS, W for a single stage rocket. And now I'm trying to figure out the what should be the value of n I should select that can give me a maxima of WS. So again, I differentiate it, I equate the derivative to 0. Alright, and on doing that, when I try to do that, I noticed that actually the derivative is always positive. So it's a monotonically increasing function, which means that even if we choose n to be infinite, okay, whatever value of omega of WS we get by putting n as infinite, that is the maximum speed that we can attain. Alright, and on doing that, the speed that we get is 5.76. So with a single stage rocket with the given values of R and V, the maximum speed that we could have obtained was 5.76 km. But with a two-stage rocket, we were able to achieve the speed of 10 km per second. So now I can surely say that yes, two-stage rocket is definitely better than a single stage rocket. Right. So guys, I hope you enjoyed this question. Now comes the time for the teaser question. Now, what is the purpose or what is the intention of giving the teaser question, guys? First of all, you can take note of this email ID. So I'll be giving you a teaser question, and right now I will not give you the answer to the teaser question. What I expect is that some of you, maybe the most curious ones or the ones who want to study from our teachers, from VUS teachers, alright, very fabulous, great teachers. If you want to compete in Olympiads, senior or junior Olympiads, and you want to study from us, I'll show you a question. You write a solution of that question, whatever you can think of, alright, and you mail it to us on this email ID. Okay, guys, keep in mind, even if you are not able to solve the question, we will be focusing upon your thought process. We will be interested in knowing what you are thinking, what logic you are giving, how you are defending your thought process. Okay, so do not think that if you are not able to solve the question, you should not send us anything. If you have a good thought over whatever question I'm going to give you, if you are able to think something on it, and you may be very near the answer, or just share your thought with us. If it's a novel thought, we would like to know them. And if we find that you are curious enough and you are interested in studying from us, and you deserve to be taught by our teachers, our VUS teachers, then we will surely contact you back. Do not forget to mention your phone number, which you will pick. Okay. And of course, when you send us the mail, we'll get your email ID. We'll be responding to the same email ID. So better use your personal email ID instead of any of your relatives, like your mom, dad, or sister, or brothers, you know. So here is the question. I call this question as the weight of time. Alright, I particularly have a liking for this particular question. It's a very, very interesting question. And apart from the whatever is given in the question here, there's one thought that probably was missed in the question. Can somebody tell, like, you read this question, you try this question on your own, and I'll see what solution you can send to us for this particular question. Alright guys, with that thought, I'll bid farewell to you for now. I'll come back with another session. I hope you enjoyed this session. Bye guys, take care.